told you that every time we drew an angle, it would be in standard position. So let's say I have an angle in standard position. So standard position means the vertex is at the origin, the initial side is the positive x-axis, and the terminal side can be anywhere else. So let's just say it's right here. So this is my angle theta. Theta is just a variable representing an angle. It could be called angle A or B or anything else for that matter. It's just common in trig to use some Greek letters. If I took a point on this terminal side, any point is an ordered pair. So it has an x and a y value. My question is, how far is it from that point to the origin? So the origin is our vertex. What's that ordered pair at the origin?
0, 0.
Mm-hmm. How would we figure out how far apart those things are?
X minus X plus Y.
Close. It's the distance formula. So the distance formula is x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So if we plug those in, we get x minus 0 squared plus y minus 0 squared. So x minus 0, that just gives me x squared plus y squared. So that is representing the distance from these points, or really the length of this little segment. In general, we are going to call this length r. So that tells us r is x squared plus y squared. That is the first important piece we need today. Eventually we'll be looking at circles with this, so r is representing the radius of that circle. You know, if I were to take this whole circle, r is your radius, so it's just that distance. Now we are going to write the definitions for the 6 trig functions. Xy is just any point except the origin on the terminal side. Okay, the origin is on the terminal side, but that doesn't tell us much, so we need some other point. We have already stated that r is going to be the square root of x squared plus y squared. So I'll give you a second to write what you want from this little preface, and then we will go through the 6 definitions. First of all, I want to talk a little bit about how to read these things. This is not sin. That represents, that SIN stands for sine. So this is read sine of theta. Theta is just representing some angle. So sine is a ratio. It is defined to be y divided by r. The y being the y value of your point. We know r is that distance from the point to the origin. So that's our ratio for sine. Next one, this isn't cos, this is cosine of angle theta. And cosine is x divided by r. Tan, that's called tangent. Tangent means y divided by x. Now if you know those 3, the others are actually just reciprocals. This CSC stands for cosecant, and that is just the reciprocal of sine. So it would be r divided by y. SEC, that is secant. So that's the reciprocal of cosine, so that would be r divided by x. t, that is cotangent. That's reciprocal tangent, so that would be x over y. Okay. These 6 definitions, we are going to talk about tricks to help memorize them, but really, you have to learn these 6 ratios. Okay, it's not a lot to memorize, but you need to know them. We will use it every day from here until the end of the semester. So it's not one of those things that you memorize for a week and then it goes away. We will still be at the end of the semester talking about sine, and you have to know what I mean when I ask for sine. So it's just talking about a ratio, you need to know which sides we're looking at. In general, if we have this picture, it does not matter which point on the terminal side you pick when you find these ratios of trig functions. So if I wanted sine of theta, we'll talk more about this tomorrow, but we can think of it like a triangle. My horizontal distance is my x, my vertical distance is my y, so we do sine y divided by r. But they could have very well picked a different point on that terminal side, and it actually turns out that if you do y divided by r in that red triangle, you get the same thing as you would have in the orange one. Or maybe you picked a point all the way back here and you would get the exact same thing. Why would all of those ratios be the same? What kind of triangles are those?
Right.
They're all right triangles, and they all have the angles in common, so these are similar triangles. Didn't we just talk about how similar triangles are proportional? And so that's why. So later on, I may ask you to find sine of an angle, and I could give each one of you a different xy on that line, and all of your ratios would turn out to be the same. So it's not going to matter which point on the line you pick, just as long as you get one of them. All right. Questions there? That is